In this lesson, you will simplify radical expressions by using the product property of square roots, and we'll simplify radical expressions using the quotient property of square roots. We're going to focus just tonight and tomorrow on the product property, and then the next lesson we do tomorrow night will be just on the quotient property. I'm going to separate it into 2 days. So a radical expression is an expression that contains a square root. And product property tells us that we can take what's inside that radical and we can break it apart into its factors, or we can take what's inside 2 different radicals and we can combine those by multiplication. So I'll show you some examples of what that means. For example, radical 12 is not a perfect square, but I can separate it into radical 4 and radical 3. Because I can take the greatest perfect square factor and divide it out, which would be 4 in this case. And 4 times 3 makes 12. And so because I can separate it as I see here, I can simplify radical 4 into 2. So this is what we call simplified form of radical 12. It's radical 4 times radical 3, which then simplifies to 2 radical 3. Let's try another example. The greatest perfect square that we can pull out of here is 9. When you think about the factors, the perfect square factors, we have 1, 4, 9, 16, 25, so on and so forth. So I'm going to pull out that radical 9 and multiply by radical 10. Now what we know is this is going to, when I simplify it, this will be simplified because there is nothing that can be divided into 10 that is a perfect square. We know that for sure. I can't take 10 divided by 4. I can't take 10 divided by 1. Well, I could, but we don't care about 1, okay? We're going to leave 1 out. So this is 3 radical 10, and that is the simplified form of radical 90. We'll try one more, radical 80. Try to think to yourself what your greatest perfect square factor would be. It can actually be divided by 16. It's radical 16, radical 5, because 16 times 5 is 80. Were you thinking of 16? Were you going high enough? You have to make sure that you go to the highest perfect square, the greatest perfect square. So then that would be simplified to 4 radical 5. Now you would know you didn't go high enough if inside the second radical you have something that can be divided by a perfect square. Well, then you know you didn't go high enough here. That's a little clue for you. So why don't you try the examples in your notes? Now, what can we do when we have 2 radicals? Well, there's actually 2 things we can do. One way to simplify this would be to simplify here first by breaking it apart into its factors. So this would be radical 3 times radical 3 times radical 5. This breaks into 3 times 5 to get 15. So when you simplify, you can realize, hey, radical 3 times radical 3 would be radical 9 radical 5, which is a perfect square. So this would be simplified into 3 radical 5. Now, I don't know about you, but I think this is a long way. Here's what I do. I multiply what's inside the radicals to get radical 45. And then I do what we just did in the last example. What is the greatest perfect square that could fit inside here? Well, that would be radical 9. And 9 times 5 is 45. So this simplifies to 3 radical 5. Now, I will practice both ways with you again, but remember, I think my way is a little faster where we just multiply and then simplify. So let's try again here. The book will tell you to break this apart into radical 2 times radical 2 times radical 7. Why? Because 14 can be divided into 2 and 7. Then you would have radical 4 times radical 7, which simplifies to 2 radical 7. Now what I would do is just multiply inside so that I have 2 times 14, which is 28. And then I know the greatest perfect square I can divide out of here is a 4. So this would be radical 4, radical 7, which simplifies to 2 radical 7. Now you can choose either method, but try the examples in your notes. Now when finding a principal square root, you have to be sure that your result is not negative. So what we're going to do is when we simplify anything in the radical, we have to make sure it's positive. So when you see a number here with a lot of variables, what I recommend doing is breaking it apart. What I mean by that is separating it into your number, and then go variable by variable. I took everything and separated it apart. Now we're going to simplify each piece. This I can break into radical 4, radical 10, which simplifies to 2 radical 10. The square root of x to the 4th is x squared. The radical is gone because this can be simplified. Here's a clue for you. All even powers will be able to be simplified. Here I have an odd power. This is radical 5. So all I can do is pull out the greatest number of even, which would be 4. So this is radical y to the 4th, radical y. 4 plus 1 makes 5. Well, because the 4 is even, I can simplify it into y squared, because the square root of y to the 4th is y squared, but that y stays in the radical because I could not break it down. Z cubed, the greatest even is 2, so it's radical z squared times radical z, because 2 plus 1 is 3. I can simplify radical z squared into z, but this radical z stays radical z. Now I put everything that is outside the radical together. 2x squared, y squared, z. Just to double check, got it, got it, got it, got it. Now I put everything that's inside the radical together. Radical 10, y, z. Got it, got it, got it. And this is your simplified form. So I highly recommend separating it out and going piece by piece, keeping what's outside the radical outside, what's inside inside. Those of you that are very messy, you might want to use graph paper, because I don't know how you're going to keep this organized and keep those radicals organized if you don't be meticulous and exact and neat, okay? So let's try one more example together. You do this one with me. Let's try it together, and then I'll have an example for you in your notes. So let's separate it out. Radical 90, radical x to the 3rd, radical y to the 4th, radical z to the 5th. Separate it out piece by piece. Now, radical 90, greatest perfect square would be 9. So this is radical 9, radical 10, which simplifies to 3 radical 10. Now, x cubed, that's odd. So I take the greatest even, which would be x squared, and then 2 plus 1 is 3. So this would simplify to x, radical x, because radical x squared is x, and this has to stay in the radical. Now, radical y to the 4th, that's even, so it would just simplify to y squared, and we can just move on. Z to the 5th, well, that's odd. So I pull 4 of them out because that's the greatest even, and then I have 1 z left. 4 plus 1 is 5. So this simplifies to z squared. This stays radical z. Everything outside, 3x y squared z squared. Let's just make sure we have them all. Got it, got it, got it, got it. Everything inside the radical, radical 10x z. Got it, got it, got it. So this is my simplified form. Now you try the example in your notes.